I haven't posted a video for about 2.5, 3 weeks because I've been in Mexico since the beginning of the month till I think we came back the 17th, and then I had to get stuff together, and I want to make this little video. I have to modify the steady rest on the Mazak to put coolant through the jaws, and so that's what this video is going to be about. I'll include a little drone shot of the building in Mexico and the general area so you get an idea of what that's all about. Okay, today we're going to do a little quick thing to modify the steady rest jaws on the Mazak. I wanted to run flood coolant up through the jaws. I'd been using a lock line hose on top of the jaws. I'll show you a picture at the machine, and a shaving would come off the tool or something and push the line out of the way, and then I wouldn't have coolant on the jaws. So what I'm going to do is drill holes through the middle of each one of the jaws, and on the machine over here we're going to run lock line. I went down to Bass Tool here, had to run down to Bass Tool, show you a little quick hyperlapse of that in the video, running down to Bass Tool and get some little lock line fittings of sorts to connect the coolant lines. There's a coolant line coming up to the steady rest already. The machine's built that way, and it has a and I put a T in it, and I got 3 outlets, one for each one of the jaws, and a little valve, lock line valve on it. All I got to do is hook this flexible line between the jaws where I drill the hole and tap it with a 1/4 inch MPT, and then drill a hole through the actual bronze jaw itself so that the coolant comes up through and distributes it on the part as the part rotates in the steady rest. So I'm going to do a little quick thing today to do that. Drill holes to the jaws and the tips that are on the bronze tips that are on the jaws themselves, so that the coolant can go through the jaws instead of having a coolant line over the top of it, which might get disturbed by shavings or whatever, or have clearance issues with the tool itself hitting it. So we're going to go through a little setup here to do that and drill the 3 jaws on the part. I'm gonna come over here. Let me move the steady rest up here on the machine. Normally you select this work rest mode, and then you would jog that dog. See that dog thing there? It has to line up with that piston on there. But there's kind of a sensor or something, so when it gets to that point, actually it's this one up in the front here for the steady rest. When it gets up to that point, you manually jog it with the key here, and you can see the machine moving, and then it gets up to the point and the key starts to blink, so you can turn to connect on, and it engages that. I don't know if we can see it here. Maybe we can see it if I get up close. You see that right here? This kind of a piston engages with this dog on the machine's Z-axis, so that you can jog it. You can do this automatically as well in a program, and you jog it forward, and you can move this steady rest and then clamp it down. I don't normally do it in the program. I just do it manually usually, because it's not really necessary most of the time to do it in the program. So I'm going to just jog it up here so I can get closer and explain what we're trying to do. I'm going to disconnect it there in the Z-axis. Now the jaws of the steady rest are machined like this, where, if the camera would focus on that, where they go into the body of the steady rest through these bores like this, and that key slot lines up with this slot that's milled in the body, and this clamping device, this clamp, goes in there and lines up on that slot, and also keeps the jaw from rotating as well, and as well as it clamps it once you get it adjusted. So that's the way the jaw itself works. This is the tip to the jaw, which in this case I made them out of beryllium copper, because that's just what I had on hand. Or they could be bronze, or the nuts are bronze. You can kind of see the difference in color between the bronze and the beryllium copper. So that the nut goes in between here, and it fits kind of nice and close in that slot, and it adjusts this, it engages that Acme thread on the jaw, and it moves the jaw in and out. So there's one of these nuts that goes in here and over here like this for that. But what I had been doing was I would hook a lock line onto this valve here and just run it over the top and spray coolant down on the jaws. But sometimes a shaving or whatever, or a tool with might come close and hit that and knock it out of the way, and then you don't have coolant on your jaws, and if your part's rotating, it could cause these jaws to overheat. So what I'm planning to do is take a coolant line, a lock line hose, and come it right into the jaw. So we drill and tap. Well, actually we're going to mill the thread. We're going to drill and mill the thread for 1/4 inch MPT all the way through the jaw here and come out inside this counterbore, and that counterbore mates to the end of this tip piece. So we'll drill a hole through here and it'll come out here, and so we'll turn this around and we'll mill a slot in here to distribute the coolant out over the radius of the jaws. Now this jaw has the radius for the 1 3/4 diameter of the part that I'm doing, and over here, I'll set these aside here, we have another set of jaws that has a smaller radius for the middle of the part that we use to support the middle when it's being turned and also milled to, it's kind of got a triangular cross section. It's not really, it's almost star shaped. You can see, let's see if the camera will focus on this. So that's the shape of the middle of the part, and in order to mill that long distance, I actually mill, I have to support it in the middle with those jaws, and you have to back away the front jaw and mill on the front, and then move the front jaw in and back away the back jaw and mill on the back in order to get this to the shape like this, with this narrow middle, and have it supported. Otherwise it would just vibrate and cause all kinds of trouble when you try to do the milling. So today we're just going to try to, or we are going to drill and tap these for 1/4 inch MPT. Actually, I'm going to drill and mill the thread, I should say, for 1/4 inch MPT, and then we're going to drill those jaw tips so that we can hook coolant from these 3 valves up to the jaws. This one can come through, around and through here to that jaw, and of course this one can go over to that jaw, and this one can come up to this jaw. Okay, we put the part in the chuck just the normal way, chucked it out some distance, just didn't want to chuck onto the thread right here, and then we're going to set the part 0 with this dial indicator. So we'll bring it up touches and then jog it carefully until we get to 0 on the dial indicator. Then we're going to come over here to the tool data, or actually the work offset, and run the cursor down to here, and we're going to go teach 0 and input. And this number here, right here, should read 0 when we get that correct. Because the tool here has an offset on the offset page, and the Mazak takes care of that automatically. If we look at the tool data page for tool 80, which is the probe, and we see that actually it's this one. Right here has the same offset as what's been labeled on that tool as being the 0 point, or that's the length of the tool. So the Mazak will automatically compensate for that if we tell it to teach 0, and then it'll set the Z at 0. Touch the tool off here, so this 1/2 inch pin barely slid through. We can just feel it touching tip of the tool. And then we take this number on the display over here, which is, focus, 7.9965, and we subtract a 1/2 inch from it because of the 1/2 inch pin that we touched off over there with. And we're going to enter that in the tool offset. So because we have the number Here, if we go down to 47, which is what this tool is, we had this number at 0. When we saw the position display, it gave us the total length that we're sitting in front of the part from the face of the spindle. Now we got to enter in 7.4965, which is a half an inch right there on the length of our tool. And if we go back here to the position display, we should be reading in Z 0.5. So that's how you touch a tool off on this machine. It's very simple. There's a tool setter up here. When this thing folds down, it's way up there, and it's difficult to jog the tool into it. It's just as easy to set it off manually right here, just like that. So that's the way I usually do it. So that's that tool. Then we're going to go through each one of the tools and set them, which we got the gun drill right here, and we have the thread milling cutter, if that would focus. These cameras. See the thread mill. Okay, so that's the 1/8 inch MPT thread mill, and already mounted in the collet chuck. Here's the finished installation of the jaws. But I forgot, I thought I had all my lock line parts I needed, but I needed more of these. I didn't have enough of these female to female couplings, so I can't hook up this end to there and that end to there. I got to get two of them, at least two of them. But that's the whole thing with the jaws. And the coolant comes out these little holes in the jaws here. I turn the coolant on to this one and it shoots up real good. So I'm stuck on Saturday the evening. Bass Tool isn't open, so I'm gonna have to wait till Monday to get these female to female coupling things like this one right here. Okay, it's Monday morning and I got my fittings from Bass Tool here to connect the lines. So this is the way the setup's gonna look. And I'm gonna hold the part like this because I have to face this end off square, and I have to put a counterbore in here that has a plus or minus 1/1000th tolerance on the diameter and the depth. So I got to hold it pretty securely. And the reason I'm doing it on the steady wrist this way and holding around about in the middle of the part here, because I didn't really want to slide the whole part back into the chuck, because then I don't have any support on the back end of it and it could be wobbling around, causing vibration, or even causing the end of the part to be somewhat out of square with the length of the part. So I'm deciding to do it this way. I think this is going to be a little bit better to do it this way. Let me close the doors and turn the coolant on here and the spindle, and you can kind of get an idea of what this thing's going to be doing. Well, that's going to be it for this video. Just wanted to show modifying the steady rest here a little bit, and maybe I'll make a few other videos as I get further along with this part. If you got this far in the video, thanks for watching, and I hope that some of this information might have been useful to you. And please comment if you have an idea or you have a suggestion or anything at all. So thanks for watching.